Oh, Jesus.
Until we come back either Saturday
She's never had one. What's your preference? What's your preference?
Students that need help in science. There are tutoring opportunities. These sessions will take place at 7:45. Monday through Friday, starting Tuesday, September 7th. Mr. Gabriel and Mr. Sandman are available. You can locate them both in their classroom at this time. Auditions. All said you did stay at response. The fifth grade graduation on the 9th, Friday, September 2nd. We actually need to stay to fill out paperwork afterwards. If you have questions, you can share. Mrs. Meyer. All students are welcome to Friday. This Friday.
I think Mrs. K was in
Topic.
I always
Topic this week. Managing school in the COVID era. Juniors interested in taking the PSAT. Register online. If you have any questions, please stop into the guidance office. And a congratulatory to our Spearfish Spartan dance team. First place last night in the hip hop. Bell Fushin Button. May I please make you stand?
I'll dance. No, I didn't know.
United States of America.
and to the republic for which it stands, one nation, under God, indivisible.
That's all the announcements for the day.
All right. Y'all got your notes out because there's no daily quiz. You didn't have any homework. We get to just hop right in. Everyone got your notebook if you had it turned in, or notes, or pile of papers, depending on person. Again, lawful good down to chaotic evil. Pile of papers. Okay. So, a couple of things, because first quiz, everyone always asks, or someone asked. A, until I send out the text on Remind that says grades are in, here's a graph of how everyone did, don't ask me if I did it, because I didn't. As soon as I'm done grading, I put everything in Campus, and then I send out the little bar chart showing you how everyone's doing. Like, so, just don't be that kid that's checking Campus all the time. Don't be the one who's pestering me and asking me. Okay, I'm like a teenager in terms of my emotional response to being asked, did you do the thing? Did you clean your room yet? No, and I'm not going to do it for another 3 days. Because screw you. Like, I have that kind of reaction. I'm not proud of it, but it happens. How'd you feel? Was it as hopefully low stress as it should be? Okay. So, everyone who turned in their notes, notebook, all that kind of stuff, I think everyone did, short of the 1 or 2 people who talked to me and the couple who are gone. So, if you didn't, and you do not have a free block next class where you are working specifically on pre-calc stuff, okay, now leave it over there. Because I got prep next hour, so I'm going to be going through all the Algebra 2 stuff and whatever you all turn in still, okay? If for any reason you need your binder because you are doing whatever thing next hour, or this notebook is also my chemistry and I need that to study for a test tomorrow. Whatever it is, just tell me. Either A, I'll do yours first, put it on top of the pile, or B, just give it to me next time, right? Like, odds are I'm going to write it down in my physical grade book and not put it into campus for a few days anyway. So just give it to me whenever. All right, it's no big deal. It'll go in there at some point. If you aren't turning things in, though, there you run the risk that I missed it. I forgot we had that conversation because I already forgot what I had for breakfast. And oops, I put it in as missing. You're like, hey, remember, I was giving this to you tomorrow. Oh, okay. Uncheck box. Nice and simple. All you got to do is have a conversation. Okay. Yeah, here we go. We talked about matrices. Specifically, we did what a matrix is, what its notation is, row by column, how each element is labeled. We talked about adding them and multiplying them. Then I showed you why you should have known that for geometry, and there's a general clamor of table flip. Why didn't we do the entire 3-week chapter like this? Case in point, transformations. When I taught geometry, we went through the whole chapter in I think 3 or 4 days. Like, it should not take long because you just do everything in matrices. It's a lot quicker. But the other half of it was equations with matrices. It's pretty simple. You're just going to do the operations that we just talked about with these matrices. If it is 4 times p plus q, well, gee, I wonder, you're going to take 4 times p plus q. I'm betting the whole lot of you could probably just do that mental math. You do that in stages. Take the elements. Take 3 plus a negative 4 is a negative 1 times 4. Or do you need to do it in stages? Add the matrices and then scalar multiply. Whatever your flavor is. 8 plus 5 is 13 times 4. Negative 2 plus 7 is 5 times 4. Finish off the bottom row. If you need to write out more of that than just what I have, then write out more of that. Bill Murray smacks the calculator out of Egon's hand and says, "Stop that!" Two, 8, 5, negative 20, 7, 5, negative 4, negative 10, negative 40. Cool? That is a negative 8. Yeah. You. I missed one of theirs. There we go. Okay. So, if you can perform multiple operations like that, that means you can also solve matrix equations. Now, what the book wants us to do, we will not do this because it's dumb, is they literally want you to replace A and B with these matrices and say 4x, that's not even an x, 4x minus matrix is matrix plus matrix plus matrix is, like they want you to write all of that out. That's way too much writing. But if you could do the part on the previous example, why not just solve for x, right? And then perform that operation. So a plus b 1/4 times a plus b. Remember, there is no such thing as division. It's a lie. It does not exist. Multiply by the reciprocal. Okay. Oh, I haven't said that yet in here? Okay. Y'all, like, I forget which classes I do what in because we reviewed order of operations in my other classes. Y'all remember? Please execute my deranged adolescent sister. Okay. I had a kid a couple of years ago who really hated his sister, and we just ran with it. Well, with the order of operations, remember that division doesn't actually exist. You never divide. You multiply by a reciprocal. Subtraction doesn't exist. What do? You add a negative. Okay? You add the opposite. So, has anyone ever seen this? It's not multiplication and division. It's multiplication, division, left to right as you encounter them, just like a book, because they're the same thing. Case in point, Facebook math. What's the answer? Uh-huh. You will see your Aunt Becky arguing with Grandma about this on friggin' Facebook, and they'll start calling each other some trash names over basic order of operations.
It's really crazy when there's parentheses added.
But that's what they do, is someone else, it'll probably be written like this. And someone's going to say, well, you have to do multiplication before division. PEMDAS. I have to. So that's 27 divided by 27. It's 1. Then you got someone else who says, well, that's divide. That's the fraction bar. So that's 27 over 3 by 9. They're both wrong. Because when you use a fraction bar, you are automatically including a set of parentheses on there. Because the fraction bar separates numerator, denominator. It groups those things, imposing a set of parentheses that isn't actually there. This isn't 27 divided by 3 times 9. That's 27 times 1/3 times 9. Because division is a lie. It does not exist. We multiply by the reciprocal. Okay? Yeah. It's always fun when you see that come up and you have grown adults bickering about something that their 12-year-old could take care of. So anyway, I don't divide by 4. I'll take it scalar multiplied by 1/4. And, well, -9 plus 5 is -4. -4 and 1/4 is -1. Right? Are we cool doing it mental math like that or not? Like, I am not entirely caffeinated enough for this yet. So if you can't and you need to write it out, write it out. Finish it off. But for matrix equations like this, I would just solve the equation for the variable and then plug in the matrices. Just like we did with example 4. Two, 3, 6, 4, 0.
Oh, yeah.
Zero's a number too, don't hate. God, that's bonkers. Like, by pre-calc, most kids got that kind of beat out of them through pain and misery of experience. When you get down to x equals 0, you're solving something and you get to x equals 0 and kids are like, no solution. Like, no, 0's a number 2. Just roll with it. Okay, how about those 3 variable systems? How many times were you solving those 3 variable systems and something disappeared and you got this as 0? Did you just kind of get that little queasy feeling just a little bit like I did something wrong? Okay, 0's a number. Roll with it. Okay. And then using matrix equation, this is more just to show you how matrices can be set up and used for data. Survey of, okay, this book's old. This book's really old. How many texts, pictures, and minutes of call that each class used? A week.
That's only in a week. That's it.
Why do they call someone?
Because phones used to actually be phones. How often do you actually use your phone to call someone? Okay. Well, I suppose, like, all old things have come back in style. Maybe calling on a phone is now retro, so it's cool. So, I said that a matrix is just an organization of data, rows by columns. So you will frequently see a table turned into a matrix. I don't need the labels on the side of it. I know that row is class, column is type of message or type of communication. And then I can just have a 4x3 matrix. Now, how it's used in terms of matrix equations and expressions, they say if, okay, this is how nowadays you go over your data limit, they charge you an arm and a leg. And even that is circumvented by families saying, screw it, we're just going to go unlimited. Because I don't know many carriers anymore who don't just do unlimited, right? Before that, there's a data limit. Like, my wife and I together shared a total of 3 gigs per month. Okay? And when I say used to, I mean as of like 3 months ago. Because we're on Wi-Fi or we don't use it. Back in the day, you had to pay for every single text. I want you to think about every message that you send on Instagram, Snapchat. Okay? Oh, no. Snapchat is data. That's data specifically. That would be on the old plan, sending something through anything web-based would have been more than picture. That would have been like $1.50 per message. Yeah. So back in the day, you'd have kids with old flip phones or the old Nokia bricks, and to send a text message, it would cost you 10 cents. Every message that you sent. Now imagine a kid who doesn't understand that fully. They just got a phone and they're texting with their friends all day. Every message is 10 cents. I want you to think about every message that you send back and forth with your friends on any platform right now, if that was just a text message instead. Grand total, how many do you think you send a day? Okay. All of it. Think of all of it. Go to social media. Social media wasn't really a thing on a personal device. Instead, you would just be texting those people.
Maybe like $5.
Okay. 50 messages a day?
Yeah.
That's it?
I'm never on my phone.
Every line. Okay, who in here is the kid that is borderline ADHD and doesn't just send a message, you send 5 little messages? Who's that kid?
Oh my gosh.
Yeah, I'm angry.
Okay.
And then I'll be like, and then I'll be like, oh wait,
Oh, I
didn't.
My buddy Aaron, y'all remember Mrs. Bowerly, her husband? Man, when he, I can tell when he has his lunch break because my phone's like ba-ding, 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 and it's all like 3-word sentences. Okay, so yes, book is old, but how do I do a matrix equation or expression for this? Every text message is 10 cents. The texts are only this column, right? So I can just use a 4x1 matrix for that scalar multiplication. I can say it's 10 cents for these. Picture messages. Sending any form of picture was a lot more data than a text, so it costs more to do. 75 cents for those. 3473. That many picture messages in a week. I guarantee there's at least 3 kids in here who do more than that just during this class. Okay. And each minute on the phone, it charged you by the minute. God, I can't wait until we get new books. I'm tired of doing this example and having to explain to kids the ancient magic. 170, 178, and 190.
So that's 0.05.
Oh, oh. Now remember, that's not the number of calls, that's minutes of calling. So this is about 3 hours.
Only.
Okay. Okay.
That's just rude.
Figure it out. You know what? Not even that. It's going to take too long. Y'all could take 10 cents times this stuff and then just add it all together. Cool. I just wanted you to see how it can be broken up. Okay. Could you use that method of organization to figure out how would you even write this? Okay. How would you write it? You don't have to solve anything. You don't have to evaluate the full expression. I just want to see, can you write out how it would be written? So in the last problem, we were talking about each type of communication. So that's how I broke up my matrices. What's this one talking about? They're talking about not the type of messages, the class. So each matrix that you're multiplying by a scalar should be that class's information. Can you write it out? These are just numbers of kids who had a phone when they published this book.
Are these actual, like, statistics? Or did they just make it?
If they ever use real numbers, they always quote it underneath it. You'll see next to the example or the picture in the book, they'll say source and cite it. Here, I think they're just making crap up. But would it be more common that the older you are, the more likely it is you are to have a phone? Okay, nowadays, this has probably shifted down 5 years. Okay. Poll. Who had their first phone before age 13? Who had theirs before high school? Okay. All right.
Yeah, so my parents were like, but it was just like a little. It was like a
Okay.
slide. And
So, what we should be seeing here is, since we're talking about classes now, there's 100 freshmen, so there's 100 of the freshmen. 20, no commas, what am I doing? 23, 163. Plus, there's 180 of the sophomores. Right? I just wanted to make sure that we understand how the organization of them work. We don't have to go through all the number crunching. Okay? All right. Everyone got a... Your calculator of choice. Everyone hold up your calculator of choice. You should probably go get one. Okay, looks like most of us are in TI 83 or 4 land. Yeah. It works just fine. It's just, instead of the alpha shortcuts, you're going to have to go old school through the menus. You're going to have to use parentheses. The ancient magic. Okay, I want to make sure everyone has that, because the last 2 sections that we go through are 07, probability, and 08, statistics. I do think that we're going to get through both. Okay, so first up, probability. I don't know who had what class when, whether you covered it, whether you did it, even if they covered it. Hint, hint, May 2020. Okay. Collectively, the student body decided to stop doing anything around April 17th. So, maybe it was on the announcements. All right. Eyes and ears, back up here. Let's finish it off. An experiment. An experiment is anything in which you record outcomes. Okay. There are controlled experiments. There are random experiments. There are passive experiments. There's all kinds of different ones, but no matter what, you're going to record the outcomes because you were trying to analyze its data. Sample space is all outcomes, observed or recorded. Can you tell me what independent and dependent events are without using the word independent or depend? Say again louder. Oh, okay, you're thinking independent variable. Independent variable is the thing that changes in an equation. Okay? Okay, starting to come off of that, independent and dependent, one affects the other in an equation. So when I talk about independent and dependent events, they are events where one outcome does not affect the others versus the outcome does affect the others. Case in point right now, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 kids in the room. What is the probability I kick a student out at random because I just feel like it, and it ends up being Natalie? 1 in 16, right? 1 in 16. Okay? But you're only kicked out for like 10 minutes and then you get to come back. Half hour later, I decide I'm going to kick another kid out at random just because it feels good. What's the probability now that it's Natalie again? Still 1 in 16. Did the first event affect the second? No, because I'm doing it at random. And she came back. Okay, what if I kicked out Natalie, and then a half hour later, I'm going to kick someone out at random again? Now it's Mariah. 1 out of 15. What happened the first time affected the second time, because now there's a slightly greater chance that it's her. Okay, that is different between independent and dependent events. Independent. Outcome 1 does not affect outcome 2. But dependent events, the first outcome, or whichever one, will affect outcome 2. You probably all remember the marbles in a bag, right? I pull a marble out, do I put it back or not? That changes the probability for the next marble. Okay, that's the classic example. Okay, fundamental counting principle. That was one that always irritated kids when they were younger. Probably back in middle school. You remember something that was like dinner, that looks like dimner.
Yeah, I'm gonna say that.
There you go. Dinner, your side, and your drink. What happens if you can have burger, you can have taco, you can have chicken. You enjoy eating raw fish. Now soak it in lye like the Norwegians and you got lutefisk. Lutefisk is like chewing a giant loogie. You chew it and it bounces back at you. And when you try to swallow the part you chewed, the rest of it goes with. Lutefisk is so disgusting. Fries, salad, I don't know, apple. I heard a T. Okay. You get to choose one from each category. How many different meals can you have? Okay. Now you have learned by painful trial and error, probably back in middle school, the fundamental counting principle. Because somewhere along the way, you had a teacher who said, you have to do burger, fries, pop. Burger, fries, milk. Burger, fries, water. And you had to list them all out and then go burger, salad, pop. Burger, salad. And you made the whole honkin' list, right? And then after you did all of that, they're like, hey, y'all, there's 4 of these, 3 of these, 4 of these. 48.
Who would eat milk and burger and fries?
Yeah, it's just.
Milk is good, bro.
Yeah?
I mean, I enjoy myself some milk.
Okay. It might not look it right now, but in high school, 18 years and 80 pounds ago, I was sucking down at least a gallon of milk a day.
A gallon?
Gallon a day. Regular 2% for most of the day, but lunch was chocolate. A quart of chocolate milk.
Just carry around like a gallon of milk everywhere you went.
No.
But just one of them giant water bottles.
So, milk's good stuff. Okay. All right. But you learned the fundamental counting principle. It says, if I want to know what my total options are, you multiply together how many options are in each category. So, if you would, A and B, find out how many possibilities are there. Most people don't catch that.
Do we have to write down all of the
No. So what's that? 48 12, that's 144, 4, 400, 160, 560, 576. And, okay.
all 1152 combinations? Well, that's a lot. That's a lot.
Oh, yeah, 20.
Okay. Part A, who's got 576? Who has 1152? Okay, because what will happen is a lot of kids will look at 6, 12, 8, won't even read the problem. Just multiply those numbers together. But remember, soup or salad, there's two options there. So 8 by 2 by 12 by, or 6 by 2 by 12 by 8. So 1152. Okay. You're going to arrange 5 books on a shelf. You probably remember doing set up the blanks. I've got 5 books on a shelf. How many options do I have for book number 1? Book number 2? No.
4.
Because I just put a book in spot number 1.
Did I call it 120?
I put a book in spot number 2. How many for the third slot? So it's at 26, 60? Oh, 20 and 6. There we go. Do y'all remember what this is called?
5 with an exclamation point. Yeah.
Oh, it's
That is not 5. 5 factorial. Everyone find the factorial button somewhere on your calculator. We got to make sure we know where it is. You might have to dig through some math menus.
I found out that I have an imaginary numbers.
Alpha window 9. Alpha window 9.
There are alpha shortcuts for it. Everyone find it? He was being sneaky when he said you might have to go through some math menus. Literally, if you were on a TI 83 or 4, it looks like everyone in the room is. Almost. Yours would be in either data or probability would be a button for it. PRB, maybe. Okay. Do y'all know? Yeah, I can go to math. And I can go over to the probability menu, and it's got all the stuff we're about to talk about. Or, if you're on a TI 84 that's got the alpha shortcuts, alpha, this whole top row brings up shortcuts. Alpha y equals brings up fractions. Look at what's right next to it above window. Functions. These are the most common functions that we're going to use in this class, including factorial. Okay? So, just got to make sure everyone knows where things are. Okay, permutations. What we just did was considered 5 permutation 5. It was 5p5. The n and the r in the permutation formula, you all remember doing this?
Yeah.
Okay. In Algebra 1, when we first show you this, we probably have you write it out and start crossing out factorials. In Algebra 2, your teacher should have said, hey, y'all remember this? Cool, there's a button for it. I hope.
Yep.
NPR, where's the button? Besides in my bookmarks. That's terrible. That was like a D tier dad joke. Don't laugh at that. Yes. NPR and Associated Press are the closest thing we have to an objective media source right now. Yeah. Actually, if I remember right, I think it was it Reuters? I want to say it was Reuters. Someone had done like, in D&D, you have lawful to chaotic, I follow the rules, screw the rules, to good, evil, I'm going to do things for the benefit of others, screw it, I'm going to do what's good for me. And then you have that alignment. There was, I think it was Reuters, did a chart like that for factual to political leaning for all news sources. And they put it in there. And even a few years ago, you'd have something like Fox was, and when they updated it, it's like down there with propaganda now. CNN has basically just said anti-Fox. So they slid way more down the liberal side, but still higher on the factual. NPR and Associated Press are the closest to factual objective right now. They're the closest thing we got. NPR is pretty good. So if you're gonna like AM radio, Grandpa listens to. If you walk in here in the morning, you will always hear me listening to the live stream of it, SDPB. Okay. Yep.
I love that thing. That's so awesome.
But no. This is a different NPR. This is the number of things a permutation taken are at a time. So an example would be I've got 16 kids in here. How many ways could I arrange 6 of them in a line? Okay, it would be 16 permutation 6. There are 16 kids, so 16 factorial ways to arrange, but I'm going to get rid of, okay, 16p6. N minus r, 16 minus 6 is 10 factorial. Why would I do that? Why would I divide by that? Do you remember? Well, there's 16, 15, 14, 13, 12, 11, 10, 9, 8, 7 ways, right? If I line up those blanks like those books on a shelf, that's how many ways I can start lining kids up. But I'm only lining up 6 kids. So there's 16 for the first place, second place, third place, fourth place, fifth place, sixth place, 10, 9, 8, 7, 6, so that they all cancel. I only care about the first 6 places. Okay, that's why we have this formula. We don't need to use the formula anymore. We got the button. Everyone found the button? Cool. Be aware of your calculator in some like scientific models or the 83s, you would have to type number, NPR number, and then you're going to have to make sure they're in parentheses. On the 84s, they'll actually put the N and the R down in a subscript in a box. So you don't have to worry about that. You can just arrow over to say I'm done with this permutation. Next to permutation, I want you to write the big important part of it is order matters. In permutation, order matters. Okay? It matters if we have Hannah Anna versus Anna Hannah. Those are different orders, right? Right? When order doesn't matter, I want to get rid of all the repeats. Now, whether it's Anna Hannah or Hannah Anna, it's still them at the table, right? So I get rid of the repeats. Those are combinations. That's the next slide. But for now, see if you can figure out what N and R are. Right now, I'm going to make a code on an alarm system. Does the order I press those numbers matter? Okay, so it's a permutation. Figure it out. Yep, the number of times that we'll have something pop up in math class where we say, can use any of the digits. Yeah, both of them. Because I want to see if you remember how we do probability. Okay. Alarm system uses 7-digit code using digits 0 through 9. How many digits are there? 10. Because 0 counts. 0 is a number 2. Stop hating, especially you. We have 10 possible digits. I can only use each one once. That's important because otherwise it'll be 10 times 10 times 10 times 10. Okay. And we're going to choose 7 of them. I would just press the button. So 720?
I got 604,000.
10. Oh, because 3 factorial is downstairs. Oh yeah, that's way bigger. I ain't doing that one in my head. What is it? 4, 8, mutter, mutter? Okay. Okay. If a code is randomly generated, what's the probability the first 3 digits are odd? This was brand new in Algebra 2. Combinatorics. Combinatorics is where you take probability, the fundamental counting principle, and permutations or combinations, and you jam it all together in a problem. So first, here. We just said that there are 10 permutation 7 total ways to make this code. Y'all remember probability is number of successful trials over number of total trials. Number of favorable outcomes over number of total outcomes. So I'm going to put that 10p7 on the denominator because that's the total ways I can make this code. But they're asking for something specific. They say, what's the probability the first 3 digits are odd? So they've now split your successful trials into 2 parts. The first 3 digits and the remaining 4 digits. We're going to multiply 2 things together, 2 categories, right? Burger, fries. Your 2 categories. Your main dish and your sides. The first 3 digits are odd. The last 4 digits are whatever. Those are my 2 categories that I'm worried about. So the fundamental counting principle says I'm going to take number of ways it can happen times number of ways it can happen. That's total number of ways it can happen. Probability says favorable over total. And now permutations. The first 3 digits are odd. How many odd numbers are there to choose from? 0 is even.
There's 0 cookies and no one gets a cookie, so it's even.
I like that.
What?
If there's 0 cookies, no one gets a cookie, so it's even. I like that. Okay, how many are we going to choose? We're going to choose 3 of them. Okay. So, this takes care of the first 3 digits being odd. What restriction do I have on the last 4 digits? So how many digits are left to choose from?
There's 4 digits, but you're only using 3.
There's 10 total digits, right?
And you're only using 3.
How many did I just use? There are 7 digits to choose from. I don't care if the other ones are odd or even, right? As long as the first 3 are odd. And then I will choose 4 of them to finish this off. This is where having a right view calculator is going to come in super handy. We're going to start with alpha y equals, brings up a fraction. In the fraction, I will type my 2 permutations. Not that. What is it? Option 7? Okay. So 5 permutation 3, arrow over, so I'm not writing down that subscript, times 7 permutation 4, arrow over, so I'm out of the subscript. Altogether, there are 10 total options, and I am choosing 7 of them. Okay, this is why right view calculators are awesome. Even a scientific calculator, you can do this. It's just fraction boxes and then type using the NPR button. Okay? Right view calculators are called such because you can type it exactly as it's written. 1/12. Or math, change to a decimal.
How did you get yours to go for a fraction 90?
Because mine, if I look at my mode, my answers are set to automatically go to whatever I input it as. So since I input my problem as a fraction, it wrote it as a fraction. But you can always just go to math and then change to fraction or change to decimal. That works too. Okay? So 1/12 or about 8.3% chance of this happening. The actual permutation? Yes. Because this is formulaic. It's always going to be the number of option A available. Now, when I put P here, this is for permutation or combination. So if order matters, use permutations here. If order doesn't matter, use combinations here. Okay. The number of things that you have for option A, how many are you choosing from A? Times number of options for part B, how many are you choosing for part A, B? And you're going to keep doing this for as many categories as there are. Like, have you ever heard probably the card hand? What is the probability you get the dead man's hand? Aces and eights? No? Y'all live like 20 miles from Deadwood.
I work at the Saloon 10.
Okay? Aces and eights, dead man's hand, was it Buffalo Bill or whoever? Wild Bill Hickok. It got shot, and that was the hand that he had. And no? Go do some tourist crap now that the tourists are gone. After this weekend.
They do the show 4 times a day at 1:35 and 7. I've seen the ratios too.
Okay. So you're going to do this for as many categories as there are, like what is the probability that I have exactly 2 aces and 2 eights? Well, I would say number of ways I can have 2 aces, number of ways I can have 2 eights, and then I would have a third category to say number of ways I can have my 5th card. Okay, so whatever the categories are, you're going to keep doing this over the number of total things you're talking about, permutation, the number of chosen things from that total. You see how this was, there were 10 total digits. I chose 7 to make a code. There are 5 odd numbers. I chose 3 of them. There were 7 remaining digits. I chose 4 of them. Broken up just like this. Okay. You smash together fundamental counting principle, permutations, combinations, and probability. This was brand new last year in Algebra 2. Please tell me you at least, it looks sort of familiar. Okay. So, combinations, same thing except Hannah, Anna, Anna, Hannah is the same thing. Because the order doesn't matter, it's still them. So what I'll do is take that n factorial over n minus r factorial, that was permutations. I divide by an additional r factorial because that's the number of repeats that are going to happen. Case in point, if these are all the ways to arrange letters E, F, G, and H in pairs, well, if I already have EF, I don't want FE. If I already have GE, I don't want EG. I already have HE, I don't want EH. I have FG, I don't want GF. I have HF, I don't want FH. I have GH, I don't want HG. To get rid of all of those repeats, I divide by an additional r factorial. And now, blah, 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 moral of the story, it's another button. Okay? Right next to NPR, y'all saw it? Okay. So up here, I want you to write order does not matter. And the way you tell the difference is the context of the problem. Do they have a word that implies arrangement or not? If they say, what's the number of ways that students can line up from shortest to tallest? Shortest to tallest, that's a categorization. So that tells me order matters. If I say, what's the number of ways that you can be in the top 10 of your class? Because kids in PreCalc care about GPA and that kind of BS. Y'all, colleges don't care about GPA. They really don't care. The only difference is it might qualify you for a scholarship or not, and as long as you're above 3, you're good. Okay? Colleges don't care about GPA. Kids and parents and high schools tend to make a big deal out of GPA. It doesn't matter. They look at your ACT score and what classes are on your transcript. So if you have a GPA that's almost 4.0, but they see that you're taking a bunch of low academic rigor classes, you're taking a lot of art or accounting or wood shop, well, those aren't academically as rigorous. They're still just as viable. They're still just as useful. But they're going to say, well, a 4.0 when you're taking a whole bunch of shop classes versus a 4.0 when you went through PreCalc, Bio 2, Physics, AP English. They see that, they're like, okay, this kid is obviously knows more. Plus, they look at your ACT scores and say, this kid got a 22, this kid got a 29. Okay?
It doesn't matter though if you want to continue on into something.
Once you get to a college program, they want you to maintain a GPA because they say you need a C minimum in the classes you're doing. Just like you need a C minimum in here to move on to trig. Okay? Yeah, that's your class grades. That's not, oh no, I'm at a 3.7 instead of a 3.9 like my friend. No one cares. Really, no one cares. Okay? So, no. ACT is where it's at. Now, I could hop on a whole other soapbox about standardized testing and how it's normed and how it leads towards systemic privilege and all that kind of stuff, but go to Friday Forums for that. So, there are 7 seniors, 5 juniors, 4 sophomores on the PEP squad. So, you ever watch Man of the House? Anyone ever see Man of the House? Tommy Lee Jones, witness protection for Texas University cheerleaders. It's hilarious. He pretends to be their coach. Where's your happy face? This is my happy face. Leave the smile into you. Anyway, you got a whole bunch of kids. You're going to choose 12 of them to sell spirit buttons. How many ways can the 12 students be chosen? Do the kids get different jobs? Different tasks? Does the order they're chosen in matter? No, they're all just going to do the thing. So, I've got a grand total of 7 plus 5 is 12, plus 4 is 16 kids. I'm going to choose 12 of them. That's it. It's still a lot of ways, but it's a lot less ways than if the first kid chosen got to, the first kid chosen had to put the paper on the back of the button. The second kid had to do the big chunk to actually put it into the button casing. And the third kid had to package them. And the fourth kid had to, like if they had different options, now you'd have permutations. I want you to take the number you just got, multiply it by 12 factorial. That's if it was permutation instead of combination. Do you see where order mattering really monkeys with it? Okay. If the students are randomly chosen, what's the probability 4 seniors, 4 juniors, 4 sophomores are chosen? They just told me specific categories again. 4 of each category. So it's combinatorics again. You have 7 seniors. I can choose 4 of them. I have 5 juniors. I'm choosing 4 of them. I have 4 sophomores. I'm choosing 4 of them. Okay? And it's all combination because the order does not matter. Over 16 total kids, choose 12 of them. Who do what? Right? Back table, there's 4 kids. How many ways can I choose 4 kids from that table? 1. I can choose all of them. So yes, 4 choose 4 is just 1. Very good. Okay. Let's see if y'all can press the buttons right. Okay. Hannah, you good with just get that parenthesis on? Okay. Don't do that. No. Huh. I thought I still had it in here. I've had the same calculator since 6th grade. Hannah doesn't have the fraction thing, so she's got to use parentheses. I was just going to show you. Those ones didn't even have the inline display, so you don't see parentheses. You just got to remember where they are as you're pressing the buttons. I had that calculator through my 2nd year of teaching. I went all the way through college with just that thing. I was a college student. I couldn't afford a freaking graphing calculator. Are you kidding me? Those things are expensive. Those are amazing. Casios for $10 will almost do your taxes. Yeah, you're good. I mean, you want to use whatever it is you're going to have access to, right? But if you had to do it on your own, you would have to first a parenthesis to say I am beginning the numerator, a parenthesis to say I am starting my first permutation. There are 7 seniors. We don't even got that. We got to go to math. Over to probability. We choose option 3, and then we type, was it 5? We're choosing 5 of them? Or no, 4 of each, right? 4 of each. And then you would, a parenthesis to close this and say, and then you would move on to the next one. The typey, parenthesis, do the next one, typey. A parenthesis to say I'm done with my numerator, divided by a parenthesis for my denominator, a parenthesis. So you can do it without a fraction mode. You just parentheses. Okay? The emulator is really laggy, so. What was it, percentage-wise? About 9.6-ish %? Well, 0.09 is 9.6%. Remember, decimal to percent, 2 places? Okay. Hey, look at that, we're at statistics. Okay. Whew! Starting with measures of central tendency. You have been dealing with these for what, 5 years now? 6? Long time. Mean, median, and mode. You know what they are. If you don't, you're in the wrong room. Okay? Do you know why they're called measures of central tendency? Well, we don't want to use the word average, but maybe typical. Okay? Measures of central tendency are numbers that should be able to reflect the typical data point for this set. Example, there are 16 kids in the room. If I were to say the typical age of a student in this room, I'm betting it would be about 16. Okay, now we're going to have a couple youngins. We're going to have a handful who are at 17 already. We might even have 1 or 2 who are at 18 already. Okay, we don't have any 19s, do we? Okay. Yep. So, I said, the typical age would be about 16. But mean, median, and mode might not all reflect this. Y'all remember mean? Mean is, okay, first of all, please tell me that you have seen that notation before. Oh, Jeebus. Okay, this is called X bar. It is mean or average. This is sigma. Sigma is capital Greek S, stands for sum. Capital Greek S, sigma, sum. The sum of all of your x's divided by how many there are gets you your average x, your mean. So if you don't, this, maybe, okay, we need to write that. The mean is the sum of x's over the number of x's. That's what that says. Okay? You're going to see sigma twice today. The first is that big E looking thing. That's a capital Greek S. Stands for sum. Capital Greek S. Sum. Okay? Now, the difference between sample and population, you see their formulas are identical, but sample versus population will matter when you go on and take actual college stats. For us, we're just usually going to use a sample. Okay? Mean, add them up, divide by how many there are. Median. What? Middle number. So I just go in the middle. I got a push. What should I do before I push? Okay, they have to be in order from least to greatest for that to work. So you actually have the number in the middle. What happens when there's two in the middle?
You add them up and divide them by.
Because that is the mean of the two numbers, which is ironically also the midpoint formula. Okay, add them up, divide by 2. Median, mode, the number that appear most often. Next to this, I want us to write, you can have one mode. You can have two modes in which you call it bimodal. Okay. A bimodal card in Magic has two modes. I can either do this or I can do this when I play the card. Bimodal. Okay. A bimodal set of data. There are two data points that both occur the most often. After bimodal, we usually just say there's no mode. Now, technically, you could go to trimodal, quadrimodal, quintimodal. Just keep going and going and going, right? But, like, dodecamodal, okay? You don't, yeah. You can have those, but after 2, we just kind of quit and say, nah, there's no mode. I would like you all to write next to this, though. Measures of central tendency, these are numbers that represent a typical value for the data set. When is one better than the other? Next to mean, I want you to write outliers affect this. Outliers affect the mean. That's why if you ever listen to anything with news reporting, they'll talk about median house value in a town, median income. They don't talk about average. Because if you were going to talk about average in, I don't know, a town like Spearfish, you're going to have the rich people up on Snob Hill over there who are completely skewing our, wait, hold on. Yeah, it's that way. No, that's the canyon.
That way.
Snob Hill's that way, the canyon's that way. They're all rich. Okay? They all got more money than us. Well, they got more money than me. I'm a teacher. I live in Bell. Okay? Because I can't afford it. Well, outside of Bell, because Bell's disgusting. But anyway. But the mean really gets thrown off by outliers. Okay? Prove it. Ages. I told you all, that things that we already know how to do, we are not going to do the hard way anymore. Everyone got their calculator on hand? Do you remember how to do one variable statistics? Because in Algebra 2, your teacher should have said, we will never calculate these by hand ever again. Here's the button. So, the button, stat, edit. We are going to enter our data. Stat, edit, enter data. Going around the room, we are going to enter those ages, starting with, okay, 17, 16, okay, I know, I said Frank is super laggy, so, Lindsay 17, Anna? 16. 15. Nope. And already potty trained. So proud. 17.
How do you get rid of the numbers?
16.
You thought about that.
Yeah.
Oh, come on. Okay, Colby's a vampire. There we go. Come on.
17.
We might trend a little bit upward.
8. 16.
Yes, physical age, not maturational. And then, once I have all of those in, I will go to stat. I told you calculate is in two places. If I go second calculate, that does stuff on the graph. If I go to stat calculate, that finds stuff from my table, including our one variable stats. You make sure that it says the right list. If you ever have to change it, it's in secondary feature above these, so just second whatever list you want. Frequency list. A frequency list is when I have more than just the one of a category. That would be like how many kids K through 2, and then you would this. So then it would just multiply by it, so I don't have to input it over and over. See how many 16s and 17s we had? Imagine I did this for the entire school. So instead, I would have 14, 15, 16, 17, 18, 19, and then next to each one, I would say how many there were. So instead of having to put in 214s, I would have 14 next to 200, so it would just multiply and enter 14 or 214s for me. Okay, so that's what a frequency list is. We won't use it unless we got gigantinormous data. So I'm just going to calculate. Ba-doop, boop, boop, and it tells me this is why we need to know stuff. X bar, mean. Sigma x, the sum of all of your values. The total of all of your ages is 260 years. The sum of their squares, we use that to get into standard deviation. We'll get there in a minute. There's 16 of you. Hey, do y'all remember the 5-number summary? The 5-number summary was used to make my minimum, my quartile 1, my also median, my quartile 3, and my maximum. To make a box of whisker plot. Okay? That's what it'll look like because our median and quartile 1 are the same. Quartile 3 and maximum are the same. Okay? So our one variable stats, you do not have to find those on your own. I want you to take note of, maybe scribble it down in the corner, what are the median and mean right now? I see median is 16. The mean is 16.25. So whether I use either one of them, I would say that the typical student in this room is 16.25 or 16. Those are both pretty close, right? Here's why we don't want to do that all the time. Why sometimes you might want to use one over the other. Stat, edit, head all the way down to the bottom of the list. This is going to hurt my soul. How old do you think I am?
You're looking really spry, like
36, 27.
Thinking about this, guys.
How much
Maybe-
are
maybe I'm talking.
36.
Okay, at least y'all ain't saying like 40s and 50s. 36. That's detail right there, okay? 36. Okay, now look at what happens when I calculate my one variable stats. All we did was add in one clearly outlier.
Now we're all 7.
Now, the mean is going to change. The mean is going to say the typical person in this room is 17 and a half. Okay? It doesn't make sense anymore, right? Because of an outlier. Okay, let's go back to the stats. All right, stat, edit. Let's say that I'm not here. Let's say that we got a substitute in the room. Let's say, hold on.
76?
Let's say they're really hurting for subs and they bring Riff and Raff in here. Okay? Who for 4.5 years I've had a standing order in the office never to let him in my room again. So, stat, calculate. I don't know, I'm just guessing. I put 76. There's a lot of gray hairs that come here. He's the one who takes up the first half of class talking about Germany. Okay. So you don't actually get any work done, right? Now look at it. Now the typical age of a person in the room is about 20. Okay.
What is he speaking about Germany?
I think he was stationed over there or something. Like, I mean, the guy's got interesting stories, but when you're supposed to be doing actual class, yeah. Okay, World War II ended in the 40s. All right. Yeah, because my grandpa just turned 78, and he was born in 43. So he was like right in. I had to ask him. I was like, 43. That's right in the war. Do you look like your brothers? Like, was your dad overseas? Okay, no. So, and welcome back. But no, that was not the case. So, if the measures of central tendency, now those can be altered based on, look at what happened when you had an outlier. Just one outlier, especially in a small data set. Look at what happens when you say, if you talk about the average income of an area. The average income of an area, what happens when you have a crap ton of people who are earning really low wages, barely subsistence living, but then you've got a handful of multimillionaires? It's going to make the average look really good. That's why we use median for a lot of things. The median home value in an area. Well, what happens when you got a lot of dumpy houses that are like in the 30 to 120,000 area, and you got some medium houses that are in that like 120 to 220 area, at least around here, and then you've got Snob Hill, where everyone's house is like 1.2 million. Okay, what happens when you take South Dakota versus Oregon? Okay, you look at those different areas. My house, 3 bedrooms, 2 bathrooms, single floor, 2.5 acres. But because it's outside of Spearfish, I bought it at 189. Because of increase to property value, because of the projects that we've done and the increase in property value just in general. Last year it was assessed at 254. Okay. Then what happens when I take that exact same property and I move it right outside of Spearfish, just on the north side of the interstate? That is easily 350. Easily. Okay, that's why you need to use median, because averages really get monkeyed with. Okay? Measures of spread. Well, if a measure of central tendency tells me the typical data value, a measure of spread is going to tell me how spread out my data is. So if I'm dealing with the range, the greatest minus the least, if we just look at students, well, 17 minus 15, it's a range of 2 years. It's not a big deal. You toss me in there and I say there is now a range of 21 years of age in the room. That changes things, right? That sounds really bad. That's when we tossed in variance and standard deviation last year. Okay. Standard deviation, y'all seen the original Transformers? Anyone? Where Bumblebee goes and finds the big cube.
Oh, yeah.
Right? He finds the big cube, it's hiding in like Hoover Dam or something, and he touches the cube and it goes into this little box. This thing that's the size of a skyscraper, like melts down into this itty bitty little box. Standard deviation does that to your data. Standard deviation takes any data set, no matter how big or small, and it condenses it into this idea of, based on your mean, how far apart is your data? Yes.
Is that the thing where it's like a bell curve and then there's like the lines in it?
And standard deviation is how we create the normal curve. Yes. Okay. Now, we don't have enough time to go into the bell curve, but I wanted you to at least talk about this, and I wanted you to see those buttons, because when you come back on Monday, we're going to go through how do I create the normal curve, how do I play around with my data as to what is actually normal. Maybe we'll see who in here is actually normal, because there is such a thing as statistically normal. Okay, case in point, if I do that with my freshman class, I got a girl in there who's like 4'8". She's a little Oompa Loompa. And then there's also a couple of the guys in there who sprouted a little early who are already taller than me. That's going to be an interesting data set. I was just a hair under 6 foot, and then college and freshman 40. So my arches collapsed, and now I'm 5'10" and a half. Like, no joke, the weight gain actually collapsed my arches and started compressing my joints. Yeah. That's why old people shrink. Their bone density decreases, so their bones actually compact over time.
So I forgot my notebook one of the days, so all my notes are in like totally different areas.
Uh-huh.
Do you want me to like transfer them into the notes?
Oh God, no! Just hand them both in. You never have to